I am too smart. I am too smart. S-M-R-T. I mean S-M-A-R-T.
All right, welcome to day 1 of chapter 5. Today we're going to go over chapter 5, section 1, and chapter 5, section 2. A lot of this stuff, like we talked about, is review. We're just going to apply some concepts that we use from solving equations to solving inequalities. So first, we're going to take a look at solving inequalities by addition and subtraction. The same properties that we had that applied to equations apply to inequalities. So very simply, and this stuff is probably going to seem overly elementary at the beginning. If we have the inequality x minus 12 is greater than or equal to 8, we want to get the x by itself, so we are just going to add 12 to both sides, and we get x is greater than or equal to 20. It's really that easy. To check it, just put in some numbers for x that you know are greater than 20. And sometimes you can choose them close to that number, but you can also choose 100. 100 minus 12 is 88. Is 88 greater than or equal to 8? Good answer, yes, good job. Okay, so that works. For a lot of them that are this simple, you might not even have to check them. So let's go ahead and go through these. We'll check these. We'll do 1a together. You can do 1b on your own. 22 is greater than m minus 8. So to both sides of this equation, we're going to add 8. Add 8. And on the left side, 22 plus 8 is 30. Very good. By the way, that's my 6th block, pre-AP Algebra 1 class helping us out today. So m is less than 30. So that's it. Let's take a look at 1b. What am I going to add to both sides? Add 14 to both sides. Very good. And we have d is greater than or equal to negative 19 plus 14. All right. I was nervous on that one. Okay, that's it. Okay, just adding to both sides of an inequality. Okay. We can use a more concise way of writing a solution set and this is new for us. Okay, it's called set builder notation. If we went back to that first answer, the answer would actually in set builder notation look like this. It would be x, and this line right here just means such that. It means as long as. Okay, so when we solve that, it would be x as long as or such that x is greater than or equal to 20. And so we're going to work on set builder notation. I don't want you to freak out about it. Over here on the left side, you can see it spells it out for you. This is read the set of all numbers x such that x is greater than or equal to 20. And that's such that. That's what this line right here, that's what that means. We put that in there because as you go on through math, we're going to get to real numbers and imaginary numbers and complex numbers and all these different kinds of numbers where you're going to make sure that your answer is very specific. If we were to graph this, you guys have experience doing this, just graphing it on a number line. If it's greater than or equal to, the dot gets filled in. If it's just greater than, the dot would be empty. And then we go, up and we put our answer in the correct direction. Pretty simple stuff that you guys have done before. Solving inequalities by subtraction, just like addition, except for we're subtracting. It's the same. So look at the example. M plus 19 is greater than 56. If we subtract 19 from both sides, 56 minus 19 is 37. Very good. So when we do that, we're going to get m such that m is less than 37. No, greater than 37. Okay. M such that m is greater than 37. Okay. So let's take a look at number 2 on the bottom. We're going to subtract, yikes. We're going to subtract what from both sides? So we get p is less than or equal to 10. So it's g. Really easy stuff that for the most part we should be pretty comfortable with. All right. Terms that are constants are not the only terms that can be subtracted. So terms with variables can also be subtracted. So if we had variables on both sides, same rules as when we solve equations apply. We want to get the variables on one side. We want to get the constants on the other. So in this example, there were a's over here and here. So we subtract 3a from both sides, and we end up with a is greater than or equal to 6. Okay, so if we take a look down here at 3a, we're going to subtract 9n from both sides. So we have negative 1 is less than n. If we were to graph that, when you graph these, I would give yourself 3 points really. Give yourself the point that we're given and then a point on either side. You don't need to do too much work. This sometimes is tough for students. I would suggest rewriting it so the variable comes first, just making sure that the inequality stays consistent. So n is greater than -1, so it's an empty circle, and it's in this direction right here. Go ahead and pause the video right here and see if you can get 3B on your own. 3B, an answer, solve the inequality, and get a graph. Ready, go. All right, so here's what we got. We got h is less than or equal to 12. I'm pointing at the screen as though anybody on YouTube can see it. We got this right here, h is less than or equal to 12, and then our graph right there. Verbal problems containing phrases like greater than or less than can be solved using inequalities. The chart shows some phrases that indicate the inequalities. I don't think you need to write this down, but it's certainly not a bad idea to understand that when we say less than or fewer than, we're going to get that. Greater than or more than, obviously here. The confusing ones are over here. When we say at most, no more than, or obviously less than or equal to, then it's less than or equal to. And the confusing part there is that we said at most, and we think most, more, bigger, so it should be greater, but it's actually the opposite, and we'll explain that in a second. When we have at least, or no less than, or obviously greater than or equal to, then we're going to use the greater than or equal to sign. So let's take a look at a real-world example over here. Felipe needs for the temperature of his leopard gecko's basking spot, and here's a leopard gecko that Felipe has because his parents are neglectful. It has to be at least 82 degrees. So when we say at least, if you think about what that means in context, we're saying it has to be at least 82 degrees. So it should be 82 degrees or more. Okay? So when we put that on here, the current temperature we have, let's see, currently it's 62.5 degrees. So how much warmer does it need to be? Well, 62.5 plus T has to be greater than or equal to 82. Okay? And then we're just going to solve for T. So it needs to go up by at least 19.5 degrees. Practical application problems are easiest done and most often correct when students actually think about what the words are saying. Okay? Sanjay has $65 to spend at the mall. He bought a t-shirt for $18 and a belt for $14. If Sanjay wants a pair of jeans, how much can he spend? So he can't spend more than what he has left. So let's say we have 65 is the total amount that we started with. That has to be greater than or equal to the total amount that he spent. So he's already spent $32, and then he wants a pair of jeans, so 32 plus J. Okay? He can't spend more than the $65 he has, so that's why that has to be the bigger number. We subtract 32 from both sides, and we have 33 is greater than or equal to J. So what does that mean? He can spend $33, but no more. Unless he's got a credit card, and then I think Sanjay's parents are as equally irresponsible as Felipe's. Okay? Let's take a look at, that's it for 5.1. 5.2, now we're going to take a look at solving inequalities with multiplication and division, and this is where we get into the big issue with solving inequalities, and that is that when we multiply each side of an inequality by a negative number, the inequality symbol changes direction. Okay, that's the big deal. When we multiply it by a negative number, the sign has got to change directions. Okay, that's a big deal. So you need to find a way to remember that. Best way to remember it, obviously, is to practice. The multiplication properties of inequality are the same as equations. Only difference being that when there's a negative involved, we're going to change the direction of the sign. So let's take a look. We're going to start with a real-world problem this time. Of the students surveyed at Madison High School, fewer than 84 said they have never purchased an item online. This is about 1/8 of those surveyed. How many students were surveyed? So we take the 1/8 times the number that we don't know, and obviously we can't have the total number of students can't be more than how many students were surveyed. So it's less than 84. So we solve that, and what we get is, and again, we get 672. This one didn't have a negative. It's important to remember how we solve equations or inequalities when we have fractions. So that's what that one looks like. Let's take a look at the example here. Mount Kinabalu in Malaysia has the greatest concentration of wild orchids on Earth. Orchids are a beautiful flower. It contains more than 750 species, or about 1/4 of all orchid species in Malaysia. How many orchid species are there in Malaysia? Go ahead and pause the video right here. See if you can come up with an inequality on your own and solve it. Go ahead and pause the video now. All right, so tough problem there, making sure we have the inequality facing the right directions, but what we got is that there are more than 3,000 species of orchids in Malaysia. Okay. We can also use multiplicative inverses to solve. So that is when we have a problem like this. Instead of multiplying both sides by 7 and then dividing both sides by -3, we're going to do it all at once. We're going to say -7/3 times -3/7 to just get r. We're going to make sure that we switch the direction of the inequality because we multiplied by a negative. And then we're going to do the same thing on the other side. And here we're going to graph on a number line. So let's go ahead and we'll do one of these together just to make sure everybody's on the same page. And then you'll do the rest on your own. So let's take 2a. Okay, we have -n/6 is less than or equal to 8. I'm going to multiply both sides of this by -6. Okay, -6 times -n/6 leaves me with just n. I multiplied by a negative, so the inequality switches directions. 8 times -6 is -48. So there's my answer as far as that goes. My graph, it looks like this. And its n is greater than or equal to, so it's that away. So that's 2a. Go ahead and get answers for 2b, 2c, and 2d. Pause the video right here. Get answers for 2a, 2b, and 2b, 2c, and 2d. Ready? So there are answers for 2b, 2c, and 2d. You'll notice that we had some fractional answers, and we put those, these are just estimates because it's on a number line, so we have some answers right here for 15.5 and for 40/3. That's 13 1/3, so we put those there. Solving inequalities by division, but just like when we solve equations, what we do to one side we have to do to the other. Also with the caveat here that still exists that when we divide by a negative, the symbol changes directions. Here's all the division, property of inequalities stuff. But again, this is just like when we solved equations. We divide both sides by a number, and then we solve. Remembering that when we solve by dividing by a negative, the inequality switches directions. So let's take a look at 3a. We have 8p is less than 58. We divide both sides by 8, and we get, yikes, we get p is less than 58/8. I'm going to reduce that. So I have p is less than 29/4. That's as far as I can go. That's 7 1/4. So when I'm graphing that one, I'm just going to have 7, 8, and there it is, and it's less than. That's it. Okay. Go ahead and pause the video here. See if you can get answers to B, C, and D on your own. 3B, 3C, and 3D on your own. Go ahead and pause the video now. Okay, so there's our answers for 3B, 3C, and 3D. Make sure that you have those. If you don't, try them again, see if you can get those answers. What I'd like for you to do now is you're going to work on the check your understanding from 5-1, just the odds, 1 through 11, just the odds. So on that page, so you can pause the video here and work on that. And then I would like for you to work on 1 through 9, just the odds here, and make sure that we're getting those answers correct before we get to the practice. That's it for the video. Thanks so much to my 6 block class. Say bye.
Bye.
Aloha.
This is probably the most challenging record you have ever put on your turntable.
Everybody in the house make some noise!